stacks and queues in computer organization. So it's one of the fundamental concept in computer organization as well as architecture also. Through this session, definitely helpful to learn about the introduction to stack, concept of stack, and also example and what are the effect of push and pop operations and what are the queue operations and the role of stack and queue in computer organization as well as the real-time examples. So here now today, so this is a subject and topic who are having knowledge about data structure for them very easy to understand. Let's go for the topic here. Introduction stack. A computer often need to perform a particular subtask using the familiar subroutine called structure. Familiar subroutine structure here. In order to maintain information and linkage between main programs and subroutine, a data structure called stack is used. So stack is nothing but a data structure where is a linkage between the main memory, main program and the subroutine. The previous session I explained about what is subroutine and what is the use of subroutine like that. Now what is a stack? A stack is a list of data elements, usually words or bytes, with accessing restriction that the elements can be added or removed at one end of the list is called top of the stack. Other end is called the bottom of the stack. The structure is sometimes referred as a push down stack. So you know stack means what? There will be a data list of the elements will be in the there will be a top and bottom, and also follow the LIFO list in first out method. The real-time method where you can apply the stacks means image processing, pattern retrieval, and parallel processing. These areas you can apply the stack in practical life. Now we go to the concept of stack. LIFO, you know, the last in first out. The last data placed on the stack is the first one removed when retrieval begins. And also push and pop used to replacing a new item on the stack and removing the top item from the stack. Assume data stored in the stack. First element is placed in the location bottom. When new elements are pushed on the stack, they are stored successive lower address locations. We use a stack that grows in the direction of decreasing memory addresses. So remember, we are going to assume the stack where that goes in the direction of decreasing memory addresses. Let's go for diagram also. Example. So here we are going to see the diagram. Where this first stack of word items in the memory of a computer. It contains numerical values called in 43 at the bottom and minus 20 at the top. Remember, when you go for this, the role of stack in computer organization, we remove the SP, that is stack pointer, or you can say a processor register point to the top of the stack. Let's go for the diagram, better understanding. So here there will be a diagram to clearly about the structure of stack here, where I assume that the memory location start from 0 and 2 power k minus 1 here. So here we have numbers called minus 20, 17 followed by 739, and the bottom element we have a number called 43 here. And also here SP, where is SP doing, that is stack pointer register denoting the value of 28, that is the current top element of the one. So this is a general diagram where you have stack pointer. We have to consider about the stack pointer where it follow the 4 type address method here. Stack and bottom we have a number called 43 because we are going to do the effect of push and pop operation based on this diagram only. So 0 start from 0 and the memory location is up to 2 power k minus 1. See here, now we assume that if you assume byte addressable memory with a 32-bit word length, the push operation can be implemented as, how do you implement the push operation? In addition, subtract has 4, SP immediate mode, and also move new item, SP, where the subtract instruction subtract the source operand 4 from the destination operand contained in SP and place the result in SP. So it go for the decrement operation, that is a 4, decrement the point value by 4 here. These two instructions move the word from location new item on to the top of the stack, decrementing the stack pointer by 4 before the move. So before moving, the stack pointer decrement by the 4 here. The pop operation can be implemented as, if you want to pop operation, you can use statement called instruction called move SP item, then add as 4 SP. So push means what? Subtract the 4, subtract or decrement the SP pointer by 4. But pop is the operation of push. That means if you want to remove the element, what happen? You will add 4, increment the SP value here. Let's go for the diagram. It shows the effect of each of these operations on the stack. Suppose I want to insert the new element called 19 here. So 19 will be moved to the top of the stack because last in first out structure, and followed by minus 28, followed by 17, 739, and bottom we have already now 43 based on the above diagram only. So here SP denoting the stack pointer of 19. This is a decrement operation. Now go for the effect of pop. After pop, suppose I want to delete the element minus 28. What happens means it will move out from the stack, and the SP pointer incremented by 4, so it go and denote the 17. So whenever push and pop operation, you have to remember the processor pointer or stack pointer is. Push means what? The new element inserted here and denoting the SP. If at all pop means opposite of push, where it incremented by 4 and denoting the next element whatever in the stack organization. So like that you can use that push and pop in the computer organization. The role of these are the role of the stack in the computer organization. And we have some point here. If the processor has the auto increment addressing modes, then the push operation can be performed by a single instruction called. So if the process if you already have auto increment addressing modes, what happen? You can give the one instruction called move new item comma minus of SP. And the pop operation also you can eliminate by performed by move SP plus comma item. That means we are rewriting the instruction code with a shortcut method. When a stack is used in program, it is usually allocated a fixed amount of space in the memory. In this case, we must avoid pushing an item onto the stack when the stack has reached its maximum size. Suppose that a stack runs from location 2000 bottom and down no further on location 1500. The stack pointer is loaded initially with the address value 2004. So these are the weakest concept. These are things you have to remember. How do you write? What is the effect of push and pop? So start means LAFO, and remember the two instructions and follow the based on the diagram here. Now next important one is queue. Another useful data structure that is similar to the stack is called a queue, where data is stored in and retrieved from a queue on a first out basis here. Thus, if you assume that the queue grows in the direction of increasing address in the memory, which is common practice, the newer data are added at the back, that is high address, and retrieved from the front low address of the end queue. So assume that you have data structure called FIFO, where queue structure we have elements 40, 50 followed by 60 and so on, and this is the front, this is the back. So this is the lowest address and highest address. Let's go for the one more diagram. Same diagram with proper explanation. So here assume that this is the lower address where the index start from. You also know the data structure start from the 0, 1, 2 and so on. So 1, 0, 1, 2, 3 and so on. So it's the low address and high address. Whenever elements it will move from the low to high only. So it's the front one. Suppose I want to delete the first 40 element. What happened after element 40 element moved, I deleted successfully, then 50 move here and so on, 60 move here and 70 move here. Suppose I want to insert the element called 10. What will happen? I can insert the back only, not in the front end. So high address and I can insert the new element. So keep on, these elements will move. This is and also we need support of two pointers in the queue, not like stack here. So first one is the front and last one is the back here. So whenever addition of 10, 20 whatever there, it move here, and whenever they delete, suppose I assume that I am going to delete the two first elements, 40 will be moved, then 50 will be removed and followed by 60, 70, 80, 90 and 10 approximately come here. So and keep on going. So we can keep on operating the structure of queue. That's the effect of the queue in the role of computer organization. So these are things you have to remember about the stack and queue. Thank you for watching this video. Please subscribe, comment in the Hostbox channel, and stay connected with the social media. Thank you.